Maxime Viscount, who's the Director of IT for IFPEN, which is France's leading research institute on energy transition. And he's going to be speaking today about leveraging Allotrope to achieve open data compliance.
Thank you for the introduction. Maybe a foreword to explain a bit where I'm talking from and what is IFPEN, and also because PR asked this slide to be in every presentation. If you can go to the next slide. IFPEN is we are a research institute, and our goal is to advise the French government on all aspects around the energy. So whether it is climate, environment, mobility, motors, hydrogen, and also oil and gas, but it's dwindling down. And we have also an engineering school on these same topics. So Allotrope for us, as it's going to be showing on the next slide, France legislative things changed a bit in 2016 because we are now required, as is everyone paid by public money, to give access to the public to basically everything we do. And it has to be made available and in an electronic format, open, easily reusable. So it's basically fair. We talked about yesterday, we had a great presentation about fair data. Basically, it's doing this for all of our data. This electronic format, open and easily reusable, we're going to advise the French government on what this format should be, and we advised and we have decided it's going to be the Allotrope simple model for this thing, because it's really easy, especially since our main target is the research community. You don't need to have any proficiency in the HDF formats. We've had some good talks yesterday about the Python libraries to read ADF files. We believe, and it's the point, the ASM format is much easier to read. And if you are not really a computer enthusiast in a research lab, you can still read and understand what the JSON file is about, which is a great thing for us. So the presentation today is about what we do with ASM. So in the workflow that has been also is the chance of presenting last. So everything has been said before. The workflow to do this, basically in the chromatography work group or any modeling work group, to define a simple model. So for the GC model, a graph model existed for ADF, but a simple model did not exist. So we worked together with the chromatography working group led by Ben to create a connector to take some GC data into an ASM and then parse the data and store it in the database. So the focus today is going to be on the engine creating the connector and transforming the GC data. It's meant as a start of a knowledge base of maybe a developers community around folks that want to do implementations themselves. So the opposite way of what Tetra Science and other colleagues are doing here, of doing it yourselves. We start from the Chem Station XSD. So our first proof of concept was done with Chem Station. So basically from the Chem Station XSD files, which define what a Chem Station result looks like, we create a data transfer object in Java. We take the JSON schema and we create the same thing, a data transfer object, where basically we take the structure of the files and create Java classes with the exact same document. When the program runs, we take the Chem Station data, transform it into Chem Station DTO, which is mapped into an ASM DTO. Which is then outputted as an ASM file. Is it compliant? We don't know. We check if it's compliant to make sure we only output ASM files that are compliant with the process. Because this last step is important because first of all there can be mistakes in the generation process, and then because we're also making some adjustments in the JSON schema during the generation process. That's one of the main issues we faced when developing this connector. Because in order to create Java classes or C# classes or whatever in a strongly typed language, TypeScript, whatever you want, you need to use a library to convert JSON schemas to strongly typed objects. We've done this using the JSON schema to Pojo library. So I put the link. It's basically the mainstream Java library to do this. And one of the main limitations is that the all of and one of keywords are not supported by this library or are defaulted to an object, which kind of ruins the purpose of strongly typing things. It is by no means a limitation of the ASM schema. The schema is completely valid according to the specification. It's a limitation of the libraries. However, it needs to be worked around. So first step to work around that is to use the embedded version of the schema. As you might or might not know, the Allotrope Foundation ships 2 versions of each ASM schema. One of them is a lightweight schema, which has basically not much in there and makes huge numerous references to the Allotrope website to build the thing. And the embed schema has everything. It's much more comprehensive. And what we've done is basically get rid of all the all-of properties in the schema. So as you can see in the screenshot here, on the left is the canonical JSON schema. And okay, it says it's all of the properties and then an index, and we modified it to get rid of the all of properties and squash everything. I will put the commit on the repository because the analyses have to be open source, but the code we're doing on this project has to be open source too. So it's all going to be open source. As soon as the ASM JSON schema license is settled, I believe it's going to be in a few days. So as soon as this is settled, we're going to put everything on our repository. Once everything has been loaded into a DTO, then it's quite easy to do. It's just a matter of understanding which terms for ChemStation are which terms in the Allotrope ontology. Sample identifier in the sample document. What's his name? Sample info of the sample information is called description of the sample document, and so on and so forth. Another thing to look out for is for the time. It gets really awry really fast with times. For example, in the ChemStation data, the time is stored as a US format string, and if you're in Europe, you can easily make things bad real quick. So a bit more. If somebody wants to work on ChemStation data, so some more things we found out, and I've put there for posterity. As you may know, there are lots of different versions of the ChemStation data format. So far, we only support versions 179 and 181, which are what we use in the library and in the labs. You can go to the next slide. So, by the way, the fact that it is so complicated, even within ChemStation, to parse the data easily, and the formats are widely different, even within minor versions of ChemStation, it illustrates the need for a comprehensive and a standard open format. When the JSON file is generated, we need to make sure that two things. First of all, that the changes to the schema that I sold as cosmetic and absolutely not changing the functionality and the underlying model of the JSON schema is actually what this is, and then that the code is correct and the correct JSON is generated. So we're checking this with another Java library that I linked as well, to make sure that eventually the JSON file we're outputting and sending to the government's data lake, is actually a valid ASM data that can be used by anyone which using a tool from the ASM environment. The next step for us, so like I said, we support ChemStation. Next step is going to be Chameleon. So if anyone is interested into getting the data from Chameleon into ASM files, GC data, feel free to get in touch. If anyone from Thermo Fisher wants to gift us a SDK license for the advancement of science, everything is good for the advancement of science. Feel free to send some questions, to get in touch with me, to take a look at the repository for the source code of what I touched upon. So far, it's empty because, as I hope I have conveyed, it's all based on the JSON schema. At the day I'm talking, the JSON schema is not releasable on an open source license, so nothing is on the repository. And as soon as this topic is settled, everything is going to be on the repository. Thank you so much for listening to me, and I hope you have questions.
Great, thanks, Maxime.